Welcome to CE Strong, Continuing Education, where you can learn anytime, anywhere. This video course has 4 video segments or video clips that range from 10 to 15 minutes in length. There will be a course test of 5 questions after segment 2 and segment 4. You must get 80% of the questions correct to pass and receive your AIA credits. If you miss a question, you will be able to go back and correct your answer. This CE Strong video course is titled The Principles of Glass Selection for Facades and is an AIA-approved course for one learning unit for health, safety, and welfare. The course sponsor is Guardian Industries Corporation. The course format is 4 video segments with 2 tests of 5 questions each. CE Strong, through its partnership with Donovan & Associates, is a registered provider with the American Institute of Architects Continuing Education System. Credits earned on completion of this program will be reported to AIA CES for AIA members. Certificate completion for both AIA and non-AIA members are available upon request. This program is registered with AIA CES for one learning unit in health, safety, and welfare, continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA, or any material of construction, or any method or manner of handling, using, distributing, or dealing in any material or product. The learning objectives for this course includes understanding a brief history and basic terminology commonly used with glass, exploring key glass selection criteria used to assure project success, defining different types of glazing products, including, but not limited to, spandrel, safety, sound, impact, and ballistics, and analyze the aesthetic and performance qualities found in a variety of low-E coatings used on glass. This will begin segment 1. At the end of segment 2 and 4, you will be asked to take a test consisting of 5 questions. All the video segments and tests must be taken in order. Principles of Glass Selection for Facades. This course will introduce the various glass options for commercial building facades while explaining the different types of safety glazing. The course will explore the aesthetic and performance differences in low emissivity coatings and explain how to customize glass through color, textures, and patterns. The course agenda covers 3 key areas: glass in basic terms, the key selection criteria for glass designs, and the different types of glazing products that are available. Let's first start with glass, as it's related to architectural applications and the industry's basic terms. So what is glass? Glass is a transparent material from the melting of sand, soda ash, and salt cake at high temperatures, 2500 degrees Fahrenheit, followed by a controlled cooling process. Glass molecular structure is unique in that its molecules are disordered, like a liquid, but with sufficient cohesion to create a rigid structure. Borosilicate glass, used in scientific instruments, is highly resistant to chemical corrosion and temperatures. Aluminosilicate glass, used for electronic displays, is highly impact and scratch resistant. Leaded glass is used for stemware and X-ray shields. This is highly reflective, which means it can bend light. It offers high brilliance with soft surfaces for easy grinding, polishing, and engraving, such as in cut crystal glass, which is made by casting and blowing. While there are numerous glass types, we are focused on soda-lime glass, which is used on the facades of buildings and interiors. Soda-lime glass attributes include a highly visible light transmission, smooth, non-porous surface with relatively high thermal expansion. Soda-lime glass is made by a float and rolled pattern process. When we look at the ingredients in soda-lime glass, approximately 70% of every glass batch consists of silica sand. Other ingredients include soda ash, salt cake, dolomite, and iron oxide. Additionally, recycled glass, or cullet, makes up approximately 15 to 20% of every batch. The cullet is added to reduce the firing temperatures and assist in maintaining quality standards. It is the iron content in the silica sand that gives clear glass its greenish appearance. Silica sand with a lower iron content provides low iron, glass products that are more neutral in appearance. To create colored glass or tinted glass, metal oxides are added to the basic formula of glass to get a variety of glass colors. Standard colors include green from added iron, bronze from added iron and sulfur, blue from added copper and cobalt, and gray with added selenium, cobalt, and iron. Different shades can be created for each of these color families. The process of blowing glass has been used for hundreds of years. Early sheet glass can be seen in old Victorian homes. The polish plate process involves the glass being formed with a pattern on both surfaces. This pattern was then ground and polished to yield two parallel surfaces which provide excellent glass optics. It was a very expensive process, leading to today's more efficient float process. The footprint of a glass manufacturing plant is similar to all glass manufacturers. A glass manufacturing plant typically consists of approximately 800,000 square feet under one roof and employs 250 to 300 people operating in a 24/7, 365-day environment. The raw materials are transported by rail or truck and stored in the batch house at the end of the plant. These ingredients are then inserted into the furnace, which melts the materials to a temperature of 2500 degrees Fahrenheit. The liquid glass is spilled onto a bed of molten tin. The tin has a much greater density than the glass, and the glass literally floats on top of the tin, hence the term float glass. This glass is then drawn off the bed of molten tin and cooled at a very specific rate, creating the ribbon of glass. If left uncut, this ribbon can run 12 miles in a 24-hour period. Here is a brief video on the float glass manufacturing process. Congratulations, you've completed the first of 4 video segments. Please proceed to video segment 2.